Hello everyone. So today let's solve the problem string problem. Yeah. So this was asked in the Codeforces beta round 33 in the Codeforces format, right? So this is fine. So you can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Yeah. Let's see what the question states, Yaman. So this is simple. Uh, there is a guy named Valera. Valera has two lowercase strings. One is S and another one is T. Valera has two lowercase strings, right? One is has two lowercase strings S and T, and allowed character changes A to B. Allowed characters changes A to B. So this is represented by AI to BI, right? So allowed character changes AI to BI with a cost WI. So we have been given weight as well with a cost WI. If one move in one move, sorry, he can change any single character in either string using an allowed change or and pay its cost. In one move, he can change any single character in either string using an allowed change and pay its cost, right? So we have to find the minimum total cost. What we need to find here, min total cost to make S and T, right? So to make S and T identical and output one resulting identical string. So we have to output the minimum total cost. Along with it, uh, we have to output one resulting identical string. One resulting identical string. Yeah, so this is fine, I believe. If it is not possible, then we have to return -1. If it is impossible, we have to return -1. So this is the question actually. Yeah, let me read the question loud. Just listen to it carefully. So Valera has two lowercase strings. One is S and another one is T, right? And allowed character changes AI to BI with the cost WI. In one move, he can change any single character, right? In either string. In either string means in either S or T, right? So using an allowed change and pay its cost, right? So this is fine. This is one of the criteria. In one move, he can change any single character in either string using an allowed change and pay its cost. We have to find the minimum total cost to make SNT identical and output one resulting identical string, or -1 if it is completely impossible. Yeah. So this is the question basically. This is it for the question. Yep. Now I hope the question part is completely clear. I mean, two things we have to output. Just remember this one. We have to find the minimum total cost to make SNT. That is one thing. SNT identical, and also we have to output one resulting identical string. So that also we have to do. Yeah. So if you look at the input output, you will come to know actually. See here, input. So this one we have been given output. So this one is actually the minimum total cost to make SNT identical, and this is the resulting this one. What do we call identical string? UXYD. Yeah. So this is fine, I believe. So let's discuss the approach. Yeah, now we have the idea. So before this one, moving on to the approach, let me tell this one is nothing but the string S. This one is nothing but the string T accordingly with the question. Yep. So this is fine, I believe. A we have 8, X we have 13, and D is nothing but the 3 here, right? So this one I'm speaking of 8, 13, and 3. So this one is nothing but the WI, STW, right? So this one W. A we have 13. This one we can consider A. This one we can consider X to Y 13. This one A to X we can consider this one X to Y 13. Edge, so D to C edge, it consists of the 3. Basically it is W. Weight, we can just consider this one as weight. This is fine, I believe. Yeah. So this is kind of belongs to graph itself, right? See, here this one is nothing but the AX is nothing but the edge, XY is nothing but the edge, DC is nothing but the edge, and 8, 3, and C, 8, 13, and 3, sorry, it is the weight actually. We can just draw the graph in this way. So this is the string S and T actually. Yeah. So see, A, so this one, A to X, so it is going A to X. So this is undirected graph, right? A to X, we have the weight 8. Next, X to Y, we are considering. So X to Y, we have the value 13. X to Y, we have the this one weight 13 actually. And finally, we have D to C actually. I can just consider here D to C, right? So D to C. This one I can just consider different. So I'll just go with the D to C with the value 3, right? So we can just consider the graph in this way, right? So we can just consider the graph in this way. We can just consider from A to Z. So this is actually, we can just consider the graph in this way, right? So this is fine. So this is nothing but n1. We have been given what do we call? We have been given 3. That is nothing but n. And SNT string SNT also we have been given here. So this is fine, I believe. Yeah. Uh, yeah. Now we have the understanding of the input output and the question. Let's move on with the approach part. So before hopping into the approach, let me tell you, so here we will be making use of the Floyd-Warshall to solve this particular problem, right? So we will be going with a Floyd-Warshall approach to solve this particular problem. Yeah. So you should be knowing the Floyd-Warshall algorithm to implement the Floyd-Warshall method, right? So to implement it basically, right? So if you don't know the Floyd-Warshall algo, you can just go through the graph-based algorithms playlist and you can just watch the video there, right? So you should you'll not come to know about the implementation if you don't know the algorithm. I'll tell you this one straightly. So you have to know the Floyd version algorithm basically. Yep. So let's do one thing. Let's solve the problem. So let's get into the approach part basically. So string s, let's consider the same first example for the approach. So string s is this one and string t this one, right? So this is fine. We are considering uayd and u double xd, right? So this is t, and changes we know this one 8, 13, and 3 are the changes actually. A to x, x to y, and d to c, right? So this is fine. So I have shown this one. So first what we will do, we will process each index independently. For index I, let's try every target character, right? From A to Z. Either it can be from A to Z itself, they are mentioned in the question. So what we will do, so we will process each index independently. For index I, we will try this one, every target character ch, nothing but from A to Z, and we will compute the cost equals min cost of s of I to ch, nothing but the character, plus minimum cost of this one t of I to the ch, right? So using all allowed chains of transformations, nothing but shortest paths, right? So then we will pick the character with a minimal cost. Then we'll pick the character with a minimal cost. So let's imply or let's implement the same thing for this example. By considering this example, we will get to know this one even clear, right? So let's go with the index by index for this particular example. Let's go with index by index by considering the first example, right? So here, first one, when I equals to 0, when I equals to 0, right? So when I equals to 0, we will be going with u versus v, u versus v actually. This is fine. U versus u, sorry, u versus u. We will choose u. So this one, the same u we have here. Here also for the t also we have u itself. It will be u versus u actually, right? So this is fine. U versus u. We will choose u. So initially the cost will be 0. The cost will be 0. Next we will be considering when I equals 1. We are going index by index, right? When I equals 1. So here next character we have a in the s, and next character we have x in the this one t actually, string t, and we will be going with a versus x actually, a versus x, right? So first we considered u versus u actually, u versus u. So now we will consider a versus x, right? A versus x. So here best target is we have a to x. So see here, a to x, this one 8 we have 8 here, a to x we have 8, right? So a to x we have 8, x to x is 0, x to x is nothing but 0, right? So best is this one cost 8. So cost will be 8 here, cost will be 8. We'll be updating the cost 8. So when I equals to 2, when I equals to 2, see now we have to move on with the third character in s, nothing but the y, and the third character in this one, what do we call, string t. This is x, right? So this will be y versus x, y versus x. So this one will be y versus x. So here in this case, we have y to x undirected graph. We can consider x to y as well, right? X to y to x doesn't matter as it is undirected graph. X to y, we have 13, right? When we consider y to y, only y to y, it is 0. When we consider x to y or y to x, it is 13. We have the value 13. This one, we are considering this one, y to x or x to y, we have 13. So what we will do, we will update the cost to 13 here. We will update the cost to 13. Next, let's move on with the index 3, I when I equals to 3, the last one. So the last one, because see the last one here, D we have here, also D we have. So we will be going with D versus D, D versus D, right? So D versus D here. So we D to C we have, D to D will be quite obviously 0. They have not given. So cost will be 0 here in this case, right? So if D to C or C to D they have given, then if they would have, if we have given C in any of the strings, then we would have went with C versus D or D versus C, right? Respectively. Then we would have considered this one 3, actually value 3. But now they have we are comparing D with the D, right? D versus D, actually cost is 0 here in this case. Yeah. So now what we need to do, so for this we went index by index for this particular one, right? So now we will sum up all the cost. When we sum up all the cost, so this will be actually 0 plus 8. uh so this one, when I equal 0 1 2 3, 0 plus 8 plus 13 plus 0. Yeah. So this one will lead us to the output 21. So this one will lead us to the output 21. Yeah. Uh, and also resulting string will be uxyd, uxyd, right? So this one uxyd, the resulting string will be u, x, y, and d, right? 0 only u. This one x, this one next will be considering x. Yeah, next will be considering x, because this one 8 we have got, right? Next we have got 13, actually will be considering y. Next we have got d, will be considering the string d, actually. Yeah, ux y d. So what we need to do here, accordingly with the question, actually we have to output the minimum total cost to make SNT identical. Minimum total cost is here 21. And also we have to output one resulting identical string. So here one resulting identical string we have got, actually uxyd, right? So this one, if it is impossible, then we have to go with a -1. Then we have to display -1, right? So it is possible here in this case. In our case, it is uxyd, right? So 21 and uxyd is the solution that we got here, right? Accordingly with the approach that we went with. Basically, we are going with a Floyd-Warshall. So this is actually the math computation that I've shown. This is the idea basically. So we will be going with a Floyd-Warshall to solve this particular problem, right? So this is fine. Now the output that we got here is 21 uxyd, which is equivalent to the output that they have shown for the example one within the question. Now our approach works absolutely correct. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part one. So what will be the time complexity here? The time complexity would lead to pico of 26 to the power of 3, or 26 cube actually, plus L into 26 into 26, right? So pico of 26 cube, 26 cube plus L into 26 plus L into 26, right? So this is the time complexity. So what will be the space complexity? Space complexity would lead to pico of 26 square here, pico of 26 square plus L plus L, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be pico of 26 cube plus this one, L into 26, and pico of 26 square plus L. So why it is 26 cube plus L into 26 time complexity? Because 26 cube is nothing but the constant for the Floyd-Warshall, and L equals length of S for this one per position checks, actually, right? Yeah. Overall effectively it will give us big of L plus 26 cube, which is almost equivalent to big of L, right? So space complexity, we are going with the big of 26 square plus L, because um, we are considering 26 into 26 cost matrix, and the resulting string builder will be going with, right? So that you will get to know when we write the code. So the time complexity and the space complexity would be this, yeah, for the code that we'll be writing in the future. Now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Just give me a second here. Yeah. So here we will be making use of the, or we'll be going with the fast input and output. So let me import here input output package. So also we'll be making use of the different utilities. So I'll be going with the java.util.start. So this is fine. Next, let's go with a class here. So I'll just go with a public uh, class. So here this one will be what name? What shall I give here? So let me give main. itself. You can just go with any name that's relevant to the question. Actually, that's relevant to the question. This is fine. Next, let's go with the infinity value here. In this case, I'll just go with static final int. So let me go with the variable inf for the infinity. So let me give here 0x, this one followed by the 3f 4 times actually. Yeah, this is fine. Yep. Next, what we will do? Next, what we will do? So we will be going with a main method. We'll be going with a main method. So this is fine. This will be throws input output exception, right? Throws input output exception, right? So within the main method, let me go with the buffered reader and the this one. Let me paste this one over here. So let me remove this one. So this is for the this one. What do we call? Uh, Actually buffered data with the fast input, right? So this one string A, string B. So this one actually for this uh, string A, string B that we are considering here, SNT, right? So we took SNT in case of the this one approach. So that is nothing but the string A and B we are considering here. This is fine. And yeah, we don't have any space here within the this one characters within the string, so we are making use of the trim here. Don't get confused why we are making use of the trim, just to remove the white spaces. We don't have any spaces, right, for the string B and B. So this is nothing but the k we have been given 3 here, so this one also we are going with the k, right? So this is fine, man. Yep. So yeah, now what we will do, is wrong here. Why this is showing like this? We are equals new input stream data system dot in. This is fine. Trim we are going with. This is also fine. Then we are going with the integer k, integer dot pass, and this is fine. Buffer data dot return. So this one we have to trim here as well. This is fine. Now next, what shall we do? Let's go with the di. So let's here. Di is nothing but the di of u we will be considering. This will store the minimum cost to change the character from node u to node b, right? So this one, let me initialize in this way. I'll just go with the di equals new int of 26 and 26, right? Size 26 and 26. Now let's initialize all the costs to infinity initially, right? Let's initialize all the costs to infinity. So I'll just go with here for int. So this one row di. So this is also fine. Arrays dot fill. This will be row along with the infinity. Yeah, row along with the infinity. This is fine, man. Now let's go with the cost to change a letter to itself as 0. We know this one. Let's go with a for loop here. This one will be int I equals 0, I less than 26, increment I. This one has to be di of I. We have to assign this one to initially 0, right? As per what we discussed actually. So we are just going with the cost to change a letter to itself as 0 here in this case. Now we have to read k change rules. We have to read k change rules and we have to update di accordingly. So I'll just write the while loop here. While greater than actually 0, then what we will be doing here? Let me go with the string d equals here. What should I give? The same thing actually. You will be going with a buffer data dot read line here. This one. So let me give the same thing here. Also, let's go with the split. We need space, right? So I'll be making use of the split here. So this is fine. Next, let's go with we have successfully split the line into A, B, and W. Nothing but A, B, I, and W accordingly with the approach that we discussed, right? Now, we have to consider from the character index 0 to 25 to the character index 0 to 25, right? So from is nothing but U, 2 is nothing but the V, and we have to go with the cost for this direct change as well. Cost nothing but the W. They have represented cost in the form of W, right? So we can just consider int u, v, and w here in this case. So this one int u will be t of 0 dot char at of 0, t of 0 caret of 0 hyphen hyphen a. So this is fine. So let me copy this one entirely. Now let me paste this one twice and make the necessary changes. So this one I'll just consider v, and this one let me consider w. So this one has to be t of 1, right? So this one has to be t of 1 caret of 0. This remains same actually. All other things remain same. So this one we have to pass the integer, right? So this one let me consider this one instead. So let me remove. This is the total cost, right? Integer dot percent of here. This one will be t of 2 actually. This is fine. We are just going with the cost for this direct change, right? So now we are left with one thing that is nothing but within this while loop. So we have to keep the minimum cost for the direct edge u to v, right? So here multiple rules are possible. So let's go with this one, di of u v. So let me go with mat.mun of di of u v along with the w, right? Along with the w. So let me come out of this one. Now let's do one thing. Let's do one thing. Hmm, what shall I do? What shall I do? Just give me a second here. We are done with this initialization part by loop. Yeah. So let's do one thing now. Now let's go with a Floyd Warshall implementation, right? So you have to know the Floyd Warshall algorithm. So what we'll do first here, we have to compute all the pairs shortest paths on 26 node graph. As we have considered 26 letters, so we have to calculate all the pairs shortest paths on 26 node graph. Also, di of yz becomes the minimal cost to change y to z via any chain. Let's go with a 3 for loops, man. Pure Floyd Warshall implementation here. So this one will be int x equals 0, x less than 26. The characters 26 we have, x plus plus. Yeah, so this is fine. No need of this one. I believe. What do we call flare bracket? So this one will be int y equals 0, y less than 26. Let me go with y plus plus. So this is also fine. Let me go with one more for loop, int z equals 0, z less than 26, also z plus plus. Yeah, so this is fine. Now within the for loop, let me go with di of y z. So di of y z equals mat dot mun of this one, di of y z, di of yz. Let me go with di of yx as well. And also we have to go with this one. So di of yz is fine. We have to go with di of yx plus di of xz, right? So this one, di of xz. Yep, pure this one, pure Floyd Warshall implementation. So this is fine. Now let's do one thing. If the lengths differ, then it is impossible to make identical, right? So positions don't match at all. So for that also we have to write this one more condition. Let me write the simple if condition here. If a dot length here, if it is not equal to b dot length, then I'll just give here system out println -1. We have to print minus this one, right? So this is fine. Then we have to terminate from here. So I'll just give return, just return, right? We have to exit, right? So this is fine. We don't have to print anything. Let's give return. This is fine, man. Now let's do one thing. Let's go with the string builder. String builder here, why string builder? We have to build the resulting identical string as well, accordingly with the criteria that they have given in the question. So we have to build the resulting identical string. We have to output the identical string along with the total minimal cost, right? So that also we have to do. For that one will be to build this one to output the identical string. So we have to build the resulting identical string as well. For that one, we'll be making use of the string builder actually. I'll just go with the string builder c equals new string builder. This is fine. Let's create instance of it. And then I'll just go with the int total equals 0. Yeah, this is fine, man. Now for each position we have to choose the best target character. So let me go with the for loop. Int I equals 0, I less than a dot length. So this is also fine. Yep, so this will be I plus plus. So this is also fine. So within this for loop, what we will be doing? So let's go with the minimal cost for this position. So this one will be int mi equals uh infinity. Mi equals infinity. Next, let's go with the best resulting character for this position. So this one will be char best equals 0, 0. Yep. Now let's try every possible target character y from a to z. So let's go with a for loop here. So this one will be for int y equals 0, y less than 26, y plus plus. Right. So this is fine. So within the for loop, so let's go with the cost to change a dot caret of I y that is this one to y actually plus cost to change b dot caret I to y, right? So this one, how can we write this one in the form of code? So let me consider the variable cost here. So this one di a dot caret, so this is fine, of I mm, hyphen a hyphen a, right? So this one will be y, this is also fine, plus di of this one will be b dot char it. So this is also fine. I mm, hyphen a hyphen a. So this is fine. This one let me give y here. So yep. This is fine, I believe, man. So next what we'll be doing. So if this target yields the smaller total cost, then we have to choose it. So I'll just go with if here cost less than mi. Then let me do one thing. Let me assign mi to the cost. Let me assign mi to the cost. Also, let me assign best to this one. What do we call? Character A. This one plus y. This is fine. Yep. Let me come out of this one entirely. Now let's do one thing. If no reachable target, nothing but mi. If mi is still infinity, then we have to go with a impossible thing, right? So it is impossible to match at this particular position, right? So then we have to print -1. So I'll just give here if mi equals infinity, we choose this one, then I'll just go with the system out println, and here we have to print -1. Yep. Next, to terminate, I'll just get terminated here. I'll just give return. Yep. So now let me come out of this one entirely. So let's add the minimal cost for this position, meaning, so let me go with total equals total plus mi. So this is fine. Next one is let's append this one best to the C. I'll just append the best to the C. So let me come out of this one entirely as well. Now all we have to do is we have to print the minimal cost and the resulting identical string. So one is within the total, nothing but the total minimal cost. So that will be stored in the total. So this one total equals total plus mi. And another one is we have to print the resulting identical string as well, which will be present in the C actually. C actually, yeah. So both we have to do. Me give here system out println. Mm, this one. First one will be total, and the next one will be. Let me go with system out println. Let me pass C. So this is it for the code actually. This is it for the code. So before checking the code with the different inputs, let me copy paste the signature starter template. So I'll just paste it over here. So this is fine. So let me come here. So let me copy this one. It will be 21 UXYD, right? So let me paste this one and let me run this one. Yeah, we are getting the correct output 21 UXYD, right? So this is fine. Let me copy this one. The output that I need to get here as 2 and B. Let's check the same. So 2 and B, we are getting the correct output. The last one, we have to get the output -1. It is impossible here. So let's check the same thing. Yeah, we are getting the -1. So let me copy this one entirely. Let me hit the submit code button here. Let me choose B string problem, paste the code over here, and let me hit the submit button. I hope this works for all the test cases, man. Let's see. Let's wait for some time. So here in the toast, it is showing accepted. The verdict that we got here is accepted, right? So whatever the code that we have written works absolutely correct for all the test cases. Yeah. So we have, yep, we have made use of the pure Floyd Warshall. This one we have went with a Floyd Warshall implementation here, right? Pure Floyd Warshall implementation to solve this particular problem, right? So we are done with the solution part actually. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.